In this question, we're asked to compare two chemicals to each other, and we're given two chemical equations. In this case, we have to use two mole-to-mole conversion factors. First, we must balance each of these chemical equations. The next step is to identify the chemical that's in common to both equations. In this case, the only chemical that is in common for both equations is NH3. All right, we're going to start with our measured number with its units. To compare one chemical to another, it has to be done on a mole-to-mole basis using a balanced chemical equation. We have our amount of N2 given to us in kilograms, so in order to be able to use the formula weight, we're going to have to first convert kilograms to grams, and then we can use our formula weight to convert grams to moles. If we look at our units, we can see all this work results in moles of N2, because units of kilograms cancel and units of grams cancel. Now that we know the number of moles of N2, we can relate that to the chemical that's in common to both of these equations, i.e. the amount of NH3 using a mole-to-mole ratio. We are going to need two mole-to-mole conversion factors. When we have two equations, we're going to use two mole-to-mole conversion factors. The first conversion factor is going to be to convert the chemical we're given to the common chemical. So we're given N2 and we want to convert that to NH3. So we're going to use the coefficients associated with N2 and NH3. So this allows us to convert moles of N2 to moles of NH3. The second mole-to-mole conversion factor will get us from moles of NH3 to the chemical of interest, here ammonium phosphate. When we set up our conversion factors, we make sure we keep the coefficient together with the chemical. So here 3 moles NH3, and with ammonium phosphate, the coefficient associated is 1. This allows us to do the conversion between moles of ammonia to ammonium phosphate, and we see that moles of ammonia cancel out. We go back to the question, and the question asks us not for moles of ammonium phosphate, but for grams. So we're going to have to determine the formula weight for ammonium phosphate. All right, so we check our last conversion factor to see if we set it up right. We see that a mole of ammonium phosphate is equivalent to 149.12 grams. And this is set up such that moles of ammonium phosphate cancel out. We're left with units of grams as our desired unit for our answer. Now let's check sig figs. 3 sig figs, exact. 4 sig figs, exact, exact. 5 sig figs. So here we're limited to 3 sig figs, which means our final answer is going to be 887 grams.